Okay, this is the last of factoring. Another type is perfect squares. So when you have the same thing twice, it's called a perfect square. When you have the same factor twice, I should say. So it says find each product. I mean, it's no different than foiling. We're just noticing a pattern here versus other times. So there's nothing different. We're just noticing a pattern. You get the same thing twice. So when we go to factor quadratics today that are like this, we know they're going to be the same thing twice. We know they're going to be the same thing twice. So if I were to FOIL this, I'm going to get 9x squared minus 3x, same thing again, minus 3x. They don't cancel at the same type, so they combine to be double. So we're just noticing patterns. You might be given this or this and told to work backwards to get either one of these. Okay, it says the resulting products obtained in example 1 are called perfect square trinomials. See how a lot of the kids are in the hallway? Please do not do that. Because they are squares of binomials, they can be factored using special patterns. It's either going to be plus plus the same thing or minus minus the same thing. It says factor each polynomial if possible. If the polynomial cannot be factored, write prime. So we know we're going to get the same thing twice. Same thing twice. Same thing twice. Same thing twice. Can we use that method of A times C and then find them? Sure, but this is a shortcut. They're telling you that they're perfect squares. I know 4 is a perfect square, so it's going to be 2 and 2. I know 9 is a perfect square, so it's going to be 3 and 3. The signs are plus plus, so it's going to be plus plus, and it's going to be y and y. They're the same thing twice. 4y squared, check. 6y is 12y, 9. It works. So you can just write it like this if you wish. Okay, like I said, you could use that old method of A times C and find the factors, but we know these are perfect squares. So the square root of 9 is 3, and the square root of 4 is 2. We have 3 terms with a plus in the back. Lovely, sorry. Okay. Here, one moment. Okay, sorry, I had to go address that situation. I'm sorry if you heard any words that were inappropriate, not from those kids in the hallway earlier. Okay, here I have the same thing twice. So the square root of 9 is 3, the square root of 9 is 3, the square root of 16 is 4. It's a plus in the back, so it's minus, minus. Here, I should have the same thing twice. Okay, I should have a 5 and 5 because it's a 25, but what's the square root of 2? There isn't, so I'm not going to have the same thing twice, so we would just say it's prime, can't be factored. Okay, and that's it for perfect squares. Okay, we will finish this with the others when it comes to solving momentarily.